Okay, so what is a pipe? In general, a pipe is a type of real-time inter-process data stream. So basically, it's like a big queue of bytes that's sent from one process to another. Each pipe, of course, has two ends. One end writes data into the pipe, the other end reads data out. And this means that one pipe, one like pipe object managed by the operating system is unidirectional. So if you want to send data back and forth between two processes, you do need two pipes. So as mentioned, the pipes are managed by the operating system, and the data is stored in memory. So normal files, the data is stored on like a storage device, but pipes are purely in memory. This is to support the real-time communication, and that's good because it's fast. There are also two types of pipes, one being anonymous pipes, also just called pipes, and the other kind being named pipes. And these are also called FIFOs to distinguish them from just the anonymous pipes. So anonymous pipes can be created with the pipe system call. And basically, this just gives your process two file descriptors, one to read from the pipe and one to write to the pipe. And then once you have these file descriptors, you use them just like any other file descriptor with the read and write system calls. But the kind of big difference when you're using pipes, so they're supposed to be real-time communication. This means that actually these system calls can block. And what that means is basically once your program issues this system call, if some condition isn't met, the program will freeze until that condition is satisfied. So, for example, one of the more common ways this comes up is that if you try to read data from a pipe, but there isn't any data available, your program will freeze until there is data available. So these pipes are created inside the process. As you can see, basically, there's just two file descriptors that show up. So it's kind of might be unclear how you could actually communicate between processes since there's no way for another process to get access to these file descriptors, or so it seems. But actually, by using fork, we can use anonymous pipes between two processes. So let's take a look at an example. Here we have a pipe being made at the top of main, and then the program forks. And this creates or kind of leads to a parent and child process. And actually, the kind of key point here is that any file descriptors are inherited by the child. So the pipe now exists in both processes. And so, like in this example, the child actually sends a message over the anonymous pipe, and the parent can receive it. And this is actually the kind of structure that is used to, let's say, like run a command in a shell. The shell can fork and then use what's called exec to actually run the like child executable that the user asks for. And they can communicate back and forth, the shell process and the like application process, they can communicate back and forth with anonymous pipes, just like this. Of course, the kind of downside of this is that you can only use anonymous pipes to communicate between related processes that have been created by fork. And sometimes we can't really deal with that limitation. So that's what we have named pipes for.